Hello, my dear learners. First of all, I'm so sorry for uh, being this much late for uploading this session. But welcome to our final dedicated lecture, okay, and of this full workshop, okay. So far we have covered a lot of things, right? So you have successfully mastered sensors, motors, and prompt engineering over the past few weeks. All right. So this session isn't about learning a new sensor. It's about the biggest challenge in the robotic, which is integration. So you need to take all those working components, your LDR codes, your ultrasonic sensor module, your motor control, and make them work together seamlessly under the immense pressure of, uh, for say, hackathon or a final project under deadline, right? Our core objective of today's session is focusing on three key um, elements. Okay, that is making your project reliable, making it organized, and making it ready to be presented. Okay, so those are the three keys to winning any. Okay, so what is hackathon? You may not know about what is hackathon. So hackathon is basically a competition where you are given a limited period of time, and within that time you have to build something from scratch. And what will be that something? That something will be given to you as problem statement. So will be given some problems and you have to find the solution for them within a fixed period of time. And whoever gives the better solution will win. Okay, so it will be just like a competition, but for the innovators, for the engineers. All right. Okay, so let's proceed. Okay. All right. So, what is our today's lecture? So, we gonna focusing on four core pillars today, and that is first is integration, which is the technical challenges of merging all the individual pieces of codes. Okay, and then the second will be the hardware hygiene. Okay, so the often ignored physical challenges of organizing and organizing the build. Okay, so yes, you are taking. We are talking about the wares. Okay, so where you have to make sure everything is managed properly. The hardwares are managed properly, right? And the third is tasting strategies. Okay, so, or for say how to debug effectively when time is short and panic is setting in. Okay, during a hackathon. And the final is the pitch. Okay, so you have built a project, you have built a wonderful project, you have did a wonderful work, but how you gonna present that work in front of the evaluators or the judges? Okay, so for example, in this hackathon competitions, there will be judges who will be evaluating you within a few hours. So they will come to you, they will ask you a lot of questions, and you have to answer them properly. You have to pitch your solution properly. So that's is the basically the idea of pitch. Okay, so this skills separate successful project demos from promising prototypes that crash 30 seconds into the pitch. Okay, so let's get started. And if you are feeling that I'm going pretty fast, then just lower the video down using the YouTube speed option. But definitely, I think I will be modulating my speed as per the need. Okay, so this scene is nothing just about so we all say it's walk before. Okay, why? Because in the meantime, how a project doesn't work. I think you have experienced this before, right? So you have done everything good. You have a working model or working anything, any project. And the moment you start doing that project, it doesn't work. Okay. So common thing, or a common phrase you hear at any hackathon. So like before it was working, but right now it's not working. But combining systems introduce conflict. That's weren't there when the parts were isolated. Okay? So let's look at the three biggest pillars of integrated system. Okay. So the project will be which you will be building gonna be integrated system, right? So let's look into the biggest pillars of that integrated system. So the first is power drain. Okay. When the motor kicks on the voltage. Okay. So when the motor kicks on, the voltage suddenly drops in the circuit. Okay. So if your Arduino doesn't have proper decoupling or a strong power source, it can reset, okay, or burn out right in the middle of a critical operation. So always check for the power supply. Okay. So always check the power supply capacity. So whenever you are integrating a high power motor or any high power device which needs more voltage, more power, you should consider to give it an external power supply rather taking the power supply from the Arduino. Okay, so that is something which is very important. And second is the timing conflicts. Okay, this is the biggest code issue. Okay, if you use the graded delay, so you pause everything. So your ultrasonic distance measurement will be blocked for a full second by a simple LED play. Okay, so make sure you must use the delay where it's needed and how much delay is needed. Okay? So the third is the pin crashes. Okay, so this is a simple but critical error which matlab, what I say that I'm sure you haven't accidentally assigned the same pin to two different components in your final variant. That is something which you have to make sure. Pins, the variant, and a simple swap in pins, like you have swap the pins of uh, ground into the VCC and the VCC into ground, it can burn out your combo. So a simple varying error can lead to erratic behavior. Okay. So let's move into the next. So in robotics, a loose connection is a failed demo. You cannot rely on breadboards and jumper wires for a final summation. So they are for prototyping on. Okay. So you need to apply hardware hygiene. Okay. So let's review the best practice. So what do you mean by hygiene? Hygiene means everything you need to be very clean and everything should be in proper way. So that is what hygiene means. And definitely when you are building any prototype, you are building any project, you have to first make sure you do it in a prototype manner using breadboard, using jumper wares and mesh it tangle. But at the end product, your end product should be presentable. It should be, follow the hardware hygiene. So let's review some practices. So use strain relief. So don't just plug wires in. Secure the cable. Bundle with cap, ties, or tape. So a gentle tug wouldn't rip out pin. Okay. So then maintain the color coding standards. Okay. So for example, always use the red for VCC or positive wires and blacks for the ground pin. Okay. So this saves minutes during panic debugging whenever you are tracing a fault during your developing phase. And finally, keep the short wares, okay, especially for data links like Wellesley channel or SPI, which is, gonna be coming out if you explore it more. But right now, for our case, we don't need 12C or SPI like data links. But if you're using it, so make sure you keep short wares for the data links like 12C or SPI. So shorter wares basically means less noise and more reliable data. Uh, I know it's me get just uh, out of your head, but it's something you should keep in mind when you are working with projects. Okay, so the data lake lines should be short ones, which will be reducing the noise, or it will give you the proper reliable data. Okay, now now we have gathered separate codes for LEDs, sensors, and motors. Okay, now we merge the logic. In our previous sessions also, we have built some project, merging all the sensors, all the motors together, and you can try it by your own. And now you're capable of, start building your projects in Arduino. Okay, so be proud of yourself and tap your back with your own hands. Okay, so you are right now capable of building any projects using Arduino. Right? So you know the basics, you know the advanced. So the core problem, while integrating everything or merging the logic, is that it's shown in a bad merge code snippet. You can see here. So in this bad merge code snippet, uh, uh, you can see it clearly. If LED blinks uses delay of 1,000, the sensor wouldn't read for a full second. So your robot is effectively frozen for 50% of the time. Okay. Are you getting it? So in this void loop, what's happening? In the loop, I have told you what happens in the loop. So in the loops, basically, everything just repeat, and repeat. For example, we'll first execute this line. Will is saying that blink the LED, and then it will be having a delay of 1 second, and then it will read the sensor. Again, it will go back to the void loop, and then it gonna again execute this blink LED, and then again it gonna be going for a delay of 1 second, and then read the sensor. So here, what's happening? Your robot is frozen for 50% of the time. It's doing nothing. It's just waiting delay for for 1 second. So, a key which we discussed last week is a non blocking code. So, we use state machines and the millis function. Okay. If you remember the milliseconds. Okay, so, it's a milli function which every part of the code checks its timer. Okay. So which executes quickly and moves on, allowing the processor to constantly scan sensors and update the motors. Okay. So if you can see that the solution I have written that is we should use the millis. Okay. So that timers and state machines for non-blocking code. So here in this code, we can but using delay of 1 second gonna make my robot freeze for 1 second. I don't want that. I will just continuously check my sensor, right? So for that reason, we will be using the milli, where we will be having delays in milliseconds. Okay? So your immediate action item is when integrating. Focus on converting, every single delay you generated to a time checking using millis. Okay. All right. Now, the AI's role here is invaluable. Okay. So the LLM or the large language model can suggest advanced designing patterns like state machine or interrupts that you might not immediately think of, having critical hours of head scratching during the hackathon. So crucially, always remember the verification step. The AI suggests the pattern, but you must verify the pin numbers and test the final logic on the hard. Okay, so you can take help of AI in order to build your project, but you shouldn't rely 100% on building your project. So that is the key, and that is the main motive. Uh, I wanted to tell you uh, at the last. Okay, so you should use AI because everyone's gonna use AI in the hackathon. So you should use AI. You should also verify it and also use your own intelligence and brain in order to work with it. Okay, and yeah, that's the thing that we need to know. And before your final demo or presentation, you must run a smoke test. So don't just check if it works. Check if it's resilient. Okay. So let's look at the two columns of checks. So in hardware, uh, double check the physical structure. Are your batteries really charged? A simple tug on a wire can expose a critical fault. Okay. So in software check, you can see uh, like remove debug prints because they slow down the loop and can confuse the judge. Also, make sure you have coded a safety stop button. It shows professionalism and prevents runaway programs or projects. Okay. So the safety stop button can, be a very helpful thing if something goes wrong while presenting your project. So you just click one button and your project gonna abort or stop. That will showcase the professional behavior while presenting. Okay, and your action items. Save this list. Okay, uh, run to it 10 minutes before the demo. Okay. So take a screenshot of this particular slide and remember this text whenever you are into a hackathon. You check this and make sure everything works properly. Okay. And yeah, now we are at the end moment. Okay. So this lecture gonna be very, very short. Okay. Within 30 minutes. And I have kept it short because uh, here I didn't find much to explain. Okay. It is something which you gain through your experience. Even if I take a 1 hour session on how to start preparing for hackathon, it's not a competitive exam. It's something which is purely based on your experience. So the first thing is you should always participate on hackathons. Okay. And then you can gain the experience on how this things works. And now let's talk about the pitch. So pitch means how you present your project, your robot, your any of the you know projects in front of the judges, okay, in front of any of the evaluators, okay, in a hackathon. So judges are tired and have seen many projects, so don't bore them with pin 13 details. Okay, let them or tell them a story in 3 acts. Use this structure, which I have followed and I have seen many people following. That is prompt. So start from like we are solving the issue of traffic management at busy intersection. Okay. So at first, identify the problem and explain them. The second, the tech. So keep it concise. Okay. For example, using an Arduino, an ultrasonic sensor, and I'm sorry. Using an Arduino and ultrasonic sensor for car detection and AI generated state machine code. It's a very concise thing. Right? So the tech, you have to be very concise. You don't have to be go man much more deeper into what are the technologies, what is ultrasonic sensor, how it detects, and how it's get the distance and those things. You don't have to explain it because you will never get that much time to explain. You will be having just 5 minutes, 10 minutes, explain your idea, explain your project in front of the judge or in the final evaluation. That is second step. The third, the demo. Focus on golden test. Okay. This is everything. If the demo fails, best pitch in the world wouldn't save you. It wouldn't save you if this last step, which is the demo, fails. So plan a short, repeatable visual sequence. Demo means showcasing your final product, your final project. So that should be flawless. That should be so perfect. Okay. So your rule of demo should be if your project works 3 times in a row, it is ready for judges. If it fails once in between those 3 times, go back to debug it. Okay? Your robot or whatever the electronics project you have prepared for the hackathon should works 3 to 4 times in a row. Then only your project is a high probability that it will be not doing any uncertain mishap during the presentation period, okay, or during the pitches, okay, because if your pitch is very good, if your explanation is very good, ultimately your project will be judged by its working, so it should work. Okay, so my dear friend, this is how we have came at the end of this workshop where we have covered 8 lectures for more than 4 weeks. And I salute to you if you are sitting in front of your desktop, laptop, or mobile phone right now till this end of the session. You are already way more ahead than most of the people who are pursuing their engineering. Because it's not only about covering or completing a course, it's about having that dedication, having that interest, having that passion to complete whatever you have started. I am really impressed with those people who have asked me in the group that when we'll be getting the last lecture, when we will be getting our certificates. I can see how much you are excited about it. Okay. Uh, And yeah, I'm really sorry because I was traveling throughout these days. I went for an international conference. That's why I was not able to record or, follow up you guys. But yeah, finally we did it. And this is how we are at the end of our robotics workshop. And congratulations to all of you. You have learned a lot of things, guys. You have not only learned, you have, you know, act, you have done a lot of activities. You have gained a lot of experience. You have gained a lot of projects. Now you are ready to participate at any hackathon. Okay, you will be confident enough to take the lead and start a project, work on the project and pitch that project and win the hackathon. Okay, so this is how we are at the end of this workshop. Thank you so much, guys, for this much love and support. And in future, we'll bring some more interesting topic and more interesting workshop and playlist and videos regarding this. Bye bye. Take care.